Question number 2 is asking us to do what? Confirm if the following equations are dimensionally correct or not. That is to check if the equations on the either side of the equal to sign, they are what? They are the same. Once they are different, the equation is dimensionally wrong. But once they are the same, the equation is dimensionally correct. Let's take a look at that. So, let's clean this. Now, let's continue. We have our velocity. What's the dimension for velocity? Number 1. Our velocity is equals to LT raised to power minus 1. The U is also a velocity. So, the dimension will be the same as for U also. Our A is what? LT raised to power minus 2. Now, let's plug it in. V, it will be what? LT raised to power minus 1 is equals to LT raised to power minus 1, which is representing our U, plus LT raised to power minus 2, representing our A, multiplied by T, representing our what? Our time. T multiplied by LT raised to power minus 2, that will give us what? That will give us LT raised to power minus 1. Therefore, we are going to have LT raised to power minus 1 is equals to LT raised to power minus 1 plus LT raised to power minus 1 raised to power minus 1. Since all the dimensions they are the same, therefore equation number 1 is correct. Equation 1 is what? Is correct. Now, let's take a look at our second equation. What is the second equation? We have S equals to UT plus 1 over 2 AT squared. We have S equals to UT plus 1 over 2 AT squared. What's the dimension for S? S is a form of distance. It will be L. So we have L is equals to, what is U? U is what? Is the initial velocity, and that is LT raised to power minus 1 multiplied by what's our time? T, plus what's our A? Since 1 over 2 is constant and is not having dimension, we are not going to take it into consideration. Our A is what? LT raised to power minus 2 multiplied by our time T, but we are squaring it now, square. That will give us what? L T raised to power minus 1 multiplied by T. This T will cancel this T. It will remain what? L T raised to power minus 2 multiplied by T raised to power 2. That will also cancel each other. This will cancel this. So we are going to have what? Plus L. Since we have what? Consistent dimension, therefore equation number 2 is also dimensionally correct. Now, let's take a look at equation 3. Equation 3 is F equals to mb squared over r squared. That is our force. What is the dimension for force? If you remember, in the last question, we have gotten the dimension for force to be what? ML raised to power minus MLT raised to power minus 2. I think that should be correct. That is, yes, that's correct. Yes. So, we have known our mass to be m. Now let's compute it. So we are going to have, okay, let's use the next. Okay, let's use this place. We have our F equals to mv squared over r squared. Our F is m l t raised to power minus 2 is equals to m, which is representing our mass in capital letter, into bracket LT raised to power minus 1, everything square, for our what? For our velocity. And our r, which is radius, is a function of what? It's a function of distance. It will also be what? L squared. So we'll be having what? M L raised to power 2 T raised to power minus 2 over L squared. L squared will be cancelling L squared. So what are we going to be having? we are going to have m l raised to t raised to power minus 2 is equals to m t raised to power minus 2. Therefore, the equation is what? It is dimensionally, the equation is dimensionally wrong. Since what? Since the two sides are not the same, the equation is dimensionally wrong. Moving on. This question is asking us to find the dimension of the constant a and b in this equation. To find the dimension of the constant a and b in this equation. Now, let's quickly do that. For us to be able to add, subtract, or multiply any quantity, it must be of the same dimension. Therefore, p, for us to have the equation to be p plus a over v squared, the dimension of p must be equal to that of a over v squared. Therefore, we are going to have our what? Our a equals to p v squared. Since p is pressure and v is volume, let's see what we can do with that. Our a is equals to p v squared, and p is pressure, that is what? Force over area. The dimension of p, which is m l raised to power minus 1 t raised to power minus 2, and that of v is what? L cube, that is length times breadth times height, which are what? Function of distance. Therefore, our a will be equals to m l raised to power minus 1 t raised to power minus 2 multiplied by L cube square. What are we going to have? We are going to have our a to be equals to m l raised to power minus 1 t raised to power minus 2 multiplied by L raised to power 6. L raised to power minus 1 multiplied by L raised to power 6, that will give us what? L raised to power 5. We are going to have our a to be what? M L raised to power 5 t raised to power minus 2, and that will be the dimension for a. To get the dimension for b, since the equation says v minus b, therefore they must be of the same dimension. We can therefore say the dimension of a is equal to that of dimension of b. Since v is volume, what is the dimension of volume? L cube. It will be the dimension of b. Therefore, the dimension of b is equal to what? L cube. Simple as that. With this, we have been able to get the dimension of a and the dimension of b.